Hello everyone, this is a video about Turtle, and Turtle is sort of a legacy environment that comes from 60s or even as soon as the screens appeared for computers. And basically it's a very simple tool to produce some nice pictures. In week 2 there was a video in supplementary videos that introduces the turtle. So if you did not see that, you can go back and see it. I'm gonna show a really simple program first. So first of all, we need to import turtle. And then we should go and do something most basic. Turtle forward 100. And let's run it and just see what happens. Oops, I indented something for no reason. Sorry about that. So you saw that the arrow was moving and it's tracing. So the turtle is this arrow. We can hide it if we don't need it. And we can draw some shapes. If we blend them well, we can draw shapes, nice shapes using a turtle. So it's more interesting after we do repetition structures. So maybe we will return that. In any case, it's a good environment for you to blend something and create a project. And that is what programming is, like for like school kids or for beginners to create a little project and really plan step by step what the turtle should do. So let us first do something simple. First of all, slow down the turtle. Dot speed 1, so smallest speed, I think that is the smallest speed. So I don't want it to hurry too much. And then turtle right. I will rotate it 120 degrees and then do turtle forward again. Run. So turtle rotated 120 degrees, this angle, and continued to go. And for example, I can do turtle pen up, dot pen up, so that it does not trace, and then I will repeat the rotation, right rotation, and run the same distance. So the turtle did the third side of the equilateral triangle, but it did not trace it because I said pen up. So that's some of the things that you can do with the turtle, and if you want to learn a lot more from it, by all means, go and learn. So Python turtle, and you can make really nice shapes with it. So this is presumably made with turtle using various colors. Maybe we will make it someday if we have time, or at least we can look at it. So the example of our book is kind of nice and also sophisticated. So go back to chapter 3. The last section is developing this example, and I would rather just show you what it does and explain as it runs. So we have turtle, and we want it to end up in this square, and we are allowed to choose what is it? Sorry, projectile's angle. So that's turtle's angle, and judging by the picture, it's something like 60 degrees, right? Maybe 60 degrees from the direction the turtle looking at. So turtle is looking horizontally, like that way to the right. Okay. And launch force, let's say, can we actually do a fractional one? I'm not sure, but I will try. I think we can, if I remember how it implemented. And it says I missed the target, so the angle was wrong, but I think the force was right. And if we rerun it with something like 65 or 67 degrees, I think we will hit the target. So there is plenty of code, and it's like a little project that is developed for you in the book. This is Constance, by the way. We can quickly run through it and understand what is good style of programming, even for such a basic code. So first of all, we have to import turtle. We do screen width, that is like a coordinate system that is on screen, and we define where the target actually is by defining the left, I guess, left lower corner, and there is a target width, and there is something called a force vector, and we can look how it's used, and projectile speed, that is turtle speed, the smallest possible, and the angles to the north from the horizontal to the right. East is 0, east direction, and then to the north turn 90 degrees, to the south 270 degrees. So this is for commanding the turtle to go in a certain direction. And you can see all the methods for the turtle that they used, like pen up, we used that. First of all, speed of the turtle was for some reason 0. That means it goes instantaneously, so I guess that is to start somewhere. And then they should like speed it down. Okay. And finally, the interesting part is the criterion whether you ended up in the box. In the box after you used the user input and you defined distance. Force vector was 30, I think, so that's how you define distance to travel, and the angle is kind of interpreted directly. And this is an interesting criterion, how to decide whether the turtle ended up inside that box. And feel free to think about it. That's a little turtle example. Not so little, maybe just a turtle example. Okay,